Mangrove ecosystems serve a crucial role in coastal resilience. They provide numerous ecosystem services, including storm protection and nursery habitat for fisheries. Within the National Estuarine Research Reserve System, the coastlines of two reserves, Jobos Bay and Rookery Bay, are dominated by mangroves. Plants that make up a mangrove ecosystem, like the one we are flying over here in Jobos Bay, are adapted to a physically stressful environment, one that is characterized by high salinities, frequent inundation and wave action, and in this region of the world, frequent hurricanes. In September of 2017, both reserves received the effects of powerful hurricanes, which led to widespread mortality and variable forest recovery, with many locations showing very little regeneration years later. Out of this shared experience, the Mangrove Coast Collaborative was established to better understand the causes of low recovery following successive hurricanes, the effects on ecosystem services, and the implications for management. In 2022, nearly 5 years to the date, both reserves again were visited by hurricanes. The continued impacts and lack of recovery in many areas of the reserves serve as the impetus for an additional project funded by the Science Collaborative.
Hello from Rookery Bay. Did you know that of Rookery Bay's 110,000 acres, that over 31,000 acres is decorated in essential mangrove habitat? Come on, follow me, let's go check it out. All right, so we are here in a mixed mangrove forest, and behind me you see signs of regeneration, and that's even after repeated hurricane impacts. So although we find ourselves at the intersection between some man-made disturbance and impacts from hurricanes, we often find different states of recovery of such a forest. Now we have to tackle this management problem, but we're gonna do it using a collaborative approach. So what does it mean for us to have a collaborative approach? That means that we're going to engage reserve staff from beginning to end. And while doing so, we're gonna invite members of our community, our stakeholders, to be a part of our project advisory committee. We do this to ensure the usability of the research that is conducted actually helps to produce products that we can use to address reserve management needs. Join us as Danielle and Digna share out their methods and anticipated outputs with our project advisory committee.
The research objectives and outputs for this one-year project include extending the impact and recovery through September of 2023 with satellite imagery, and then assessing hydrologic regime at locations of minimal recovery, understanding that often the reason you don't have this natural recovery that's expected after hurricanes is when there's some pre-existing landscape alteration or a change to hydrologic flow related with the movement of sediments during a hurricane can lead to this minimal recovery. So the outputs we will have is mangrove change maps and hydrology data for selected mangrove plots. And this information will be used to guide management specifically for restoration alternatives, as well as prioritizing sites to do restoration and management interventions.
So the mapping, what we anticipate to have is this type of output. For example, in this map, we took only the class of mangrove for 2017 and 2018, and we subtracted 2018 from 2017. Red are losses, indicating losses of mangrove in 2018, and blue are gain of mangrove. And this type of maps help us visualize where the brunt of the damage was in that area. In this specific area, it was very close to the coast. We can see that the maximum was around 2016, 15 and 17. There was very high square meter coverage of mangrove, and it was reduced very drastically in 2018. And in 2020, yeah, it has recovered, but still not to the level of 2017. So our idea is to see with the impact of these other storms in 2022, how has been this recovery.
The idea is we'll get the temporal flow of water in and out of this basin. In this case, in Jobos Bay, there's always water standing there. We know that black mangroves do not like that, so it's no surprise that this is a standing dead forest here in this particular location. The other thing we'll be able to see is how water level changes with recent rainfall, because we'll get the records that are being recorded at each NERR has a weather station, so we'll be able to compare that information as well. And the idea is to deploy 6 of these in each reserve. And so that's why we need to come to the idea of, well, how do we want to do this? How do we want to disperse these resources to best understand what's happening at sites that are not recovering?
Well, thank you for tuning in for our sneak peek. We hope you enjoyed it, and we'll be wrapping up the Limits of Resilience project this fall, so tune in for more.